doing well, and in this video I'm going to teach you guys all about the for each loop in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Hey, what's going on, guys and gals? In this video I'm going to explain the for each loop, also known as an enhanced for loop. This is a traversing technique to iterate through all the elements in an array or other collection. The benefits is that a for each loop takes less steps and is more readable than a standard for loop. However, it is less flexible. So let's begin by creating an array of animals. So these will be animal names, so the data type will be string. Then we need a set of straight brackets. We will call this array animals equals, and then we will assign a few values. So within our array of animals, let's say we have a cat, a dog, a rat, and a bird. I'm not sure what kind of bird, just use your imagination. Now we could create a for loop to iterate once through each element of this array, but we could also use a for each loop to do this. So this is how to create a for each loop. Type for, a set of parentheses, and then a set of curly braces. So the only part that is different is the statements within the parentheses of the for loop. We're going to begin by listing the data type of our array or other collection. So we're going to list this as string because we're iterating through strings. Next, we need an index. Let's say index I, then colon. Colon represents the word in. For every string index in our array of animals. So lastly, list the array or collection name at the end. So this will iterate once for each index in our array of animals. So what would we like to do within each iteration of this for each loop? Let's display whatever I is. So this is going to be a string, whatever this data type is, so we can print this directly. And when we run this, our for each loop will display all the elements within our array. And now let's try this for each loop using a collection. An array list is a type of collection. So let's create an array list called animals this time. So array list within angle brackets, we're going to list the data type, which is string, and then we will call this animals equals new array list angle brackets, list the data type, parentheses, semicolon, and then we'll need an import at the top. Import java.util.ArrayList, and then we need to add some values to each element of this array list. Animals dot add, we're going to add a cat, then repeat the process for dog, rat, and bird. Dog, rat, and bird. And you can see that nothing has changed. So remember, a for each Each loop is useful for iterating through all of the elements in an array or other collection. It involves less steps and is more readable, but it's less flexible compared to a standard for loop. So that is everything you need to know to get started with the for each loop, also known as the enhanced for loop. If you would like a copy of all this code, I will post all of this in the comments down below. And don't forget to do me a favor and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow.
U-Track's built-in knowledge base is, well, it's whatever you want it to be.
Bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain methods in Java. So sit back, relax, and enjoy. Enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back guys and gals. In this video I'm going to explain methods. A method is a block of code that is executed whenever it is called upon. For example, when we begin our program and execute it, we begin by calling the main method. That's where we've been writing a majority of our code. So anything within this set of curly braces belongs to this main method. This time we're going to create our own method that we can call whenever we need it. So outside of our main method, make sure you don't write this within the main method, we're going to create another method, perhaps a method that will display a message such as hello. And to begin creating a method, we'll need a return type. I'll explain return types later on in this video. For now, we're going to list the word void, followed by a method name. Our main method is called main, and a common naming convention for methods is to have the first letter lowercase. So let's create a method called hello. When we call this method, it will display a message such as hello. So this will be hello with a lowercase h, then we need a set of parentheses, and then a set of curly braces. Anything within this set of curly braces belongs to the hello method, and if we call the hello method, it's going to perform whatever code is between these two curly braces. So what would we like to do when we call this method? Let's display a message such as hello. Now within our main method, we can call, also known as invoking, this method. So within our main method, we can call the hello method whenever we want. Now we have just one issue that we need to take care of, and let me explain. We cannot make a static reference to the non-static method hello from the type main. So this means that we need to precede this method with the keyword of static, because we're calling the hello method from a static method of main right here. So normally we do not need to add this keyword of static, and if you want to learn more about things that are static, I do have a video on it. But for now, we just need to add this keyword in order for this program to work for this example. So when we call the hello method, it's going to perform whatever is within our block of code. And here it just displays the word hello, and we can call this method whenever we want and however many times we want. So if we want to display the word hello 3 times, we can just call the method 3 separate times. And this method will perform its task, its block of code, however many times it is called. One feature available to methods is that we can pass a value or a variable to a method when we call it. For example, we can pass a string variable to represent a name, and then we can use that name for something within our block of code. So for example, let's pass in a name of whatever your name is. Let's say bro. We can pass in a value or a variable. So for this example, I'm going to pass in a variable called name. String name equals bro, and I'm going to pass my variable of name into my method. So if you want to pass a value or a variable to a method, when you call that method, within the parentheses, just list all of the values that you would like to pass to. to your method. The values or variables that you're sending to a method are known as arguments, and they can be confused with what's known as parameters. In order to pass some values or variables to a method, when we declare our method, we need a matching set of what's known as parameters. Think of these as the rules. In order to call this method, we need a matching set of arguments and parameters. Currently, these are not matching. We're passing in a string, but there is no matching parameter. So this is how to set up a parameter for a method. We're first going to begin by listing the data type of the value that our method is expecting. So we're passing in a string as an argument. So we need a string parameter. So we need to first list the data type, followed by a name for this value. Just to make it simple, I'm going to call this name. So we now have a matching set of arguments and parameters. And now, since we're passing in our name variable to our method of hello, our hello method now has access to a string variable of name, and it contains this value of bro. So now we can use this name for something. Let's display hello plus name. And when we call this method and pass in our name, it's going to display the word hello plus our name, hello bro. So with parameters, you don't necessarily need to keep the names of the values consistent. I could change this name to something else, like title, I guess. And then I will switch that around, and this will work just the same. So these don't necessarily have to be called the same thing, the argument and the parameter. You can change the name if you want. Even something like this would work too. I don't know why you would write it like that, but you can. So with methods, you can pass in more than one argument as long as you have a matching set of parameters. This time, let's pass in an integer value. Let's create an integer variable called age. Int age equals, and I'll set this to 21 this time. So within my hello method, I'm going to pass in my name and age as arguments to my hello method. However, we have a problem. If I attempt to run this, we do not have a matching set of arguments, name and age, and parameters. We're passing in a string and an integer, and our method has parameters set up to accept only a string. So we need to finish setting up the parameters for this hello method so that the arguments and parameters match. So we need an integer, and we will call this age, and then we can use this age variable for something. So within another print line statement, let's display UR plus age. And now this will work because we have a matching set of arguments and parameters. And before we finish this video, I would like to explain return types. We can return a value back to the area in which we called a method. So for this example on return types, I think this can be best explained with a separate example. So I'm going to clear out all of this and create a new example. Let's say we have two integer values. Int x, this will equal maybe maybe 3, and int y, this will equal 4. Well, let's create a method that will add these two numbers and return the sum, the result of these two numbers. So outside of the main method, let's declare a method static. Normally we would type void if we're not returning anything, but if we're going to be returning a value, we need to list the data type of the value that we're returning. If we're going to add two integers together and return the sum, we're going to list the return type as integer because that's the data type of the value that we would like to return. We would like to return an integer, and then we will list the method name. Let's call this add, parentheses, and then a set of curly braces. So we cannot normally finish compiling this because if we're listing a return type, we need to list a return statement. What do we want to return? Well, we're going to return an integer, but we'll have to get to that later. So let's begin by setting up the parameters for our add method. Let's say we would like an integer, let's call this x, and int y. So in order to call the add method, we need to pass in two arguments, two integers. So let's call the add method and pass in our variables x and y. And within the add method, we will add these two numbers together. We could store this within a separate variable, int z equals x plus y. And then we could return our value of z. So when we run this, what's going to happen? Well, it doesn't display anything. That's because when we return the value of z to this area in which we called our method, well, we're not currently doing anything with this value. So we could store this within a variable or display it directly to the console window. So let's store the sum within int z. Int z equals add x and y. So you may have noticed that we declared this variable twice, int z, within our main method and within our add method. This is technically legal because they are known as what's called local variables. Int z is only recognized by anything within the immediate set of curly braces. It's known as a local variable. Our add method does not recognize this int variable of z, so we could declare our own to use. Or you can rename it too. It doesn't really matter what you do. So we can store the sum of our add method within int z and then do something with it, such as display it to the console window, system.out.println z. So this will display the sum of 7. Another way in which you could write this, we don't necessarily need to store the value in which we're returning to a variable. We could just directly display it to the console window too. So within my print line, I'm going to call the add method and pass in x and y, and this will still display 7. Another way in which we could shorten our method is that we don't need to store the sum within a variable. We could just return x plus y. So let me clear this line, and we could return x plus y, and this would be valid too. So that's another way of writing this. Well, everybody, those are methods. They are really just a block of code that is executed whenever it is called upon. You can pass in values or variables known as arguments, but in order to do so, your method, when you declare it, needs a matching set of parameters. And then you could return a value if you need to. Instead of using the word void, just list the data type of the value that you're returning. So if you would like a copy of all this code, I will post everything in the comments down below. And don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow.
I didn't use Old Spice. I think I smell.
You thought no one could tell?
Hello, bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about overloaded methods in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's discuss overloaded methods. Overloaded methods are methods that share the same name, but they have different parameters. This is allowed because each method needs its own unique method signature. That is the method's name plus its parameters. They can share the same name, but they would need different parameters to give them each a unique method signature. Let's create a few overloaded methods, perhaps just a few add methods that will add some numbers together. Outside of our main method, let's declare a few overloaded methods. So for this example, we'll need these to be static. Let's return an integer, so the return type is going to be int, and this will be called add. And we will accept a few arguments, so we need to set up some corresponding parameters. Let's say int a and int b. And we will return the sum. Return a plus b. So let's create another method, an overloaded method, also called add. Wait a minute, we have a problem. So we have two methods that are duplicates. Duplicate method add in type main. They both have the same method signature. They both share the same method name as well as the same parameters where they accept two integer values. There are two ways in which we can resolve this. The first is that we can change one of the method names, and this error would go away. But that defeats the purpose of overloaded methods. The other way is that we can change the parameters that we have for each method. Let's say we would like two versions, maybe even three versions of our add method. One that accepts two values, another that accepts three values, let's say int c, return a plus b plus c, and another that will accept four values. So we'll have int d, return a plus b plus c plus d. And then our problem went away. So let's test these. I'm just going to add a print line that states which overloaded method we're using. This is overloaded method number 1. And I'm going to copy this and paste it, and we'll change the second instance of this print line to this is overloaded method number 2. And lastly, this is overloaded method number 3. So let's try this. Let's say we have an integer, int x equals add, and we can pass in between 2 and 4 integers. Now I'm going to attempt to pass in a single integer value, but we cannot run and compile this because we do not have a matching method signature. We can pass in between 2 and 4 integers. So let's try this by passing in 2 arguments this time, 2 integer values, and then let's display the sum, the result. System.out.println, our variable of x. So we end up using our first overloaded method. This is overloaded method number 1, and this will display the sum, a plus. Plus b, which is 3. And let's try and use our second overloaded method. We need to pass in 3 integer values as arguments, and we are now using our second overloaded method. And lastly, we can pass in 4 integer values, and we end up using our third overloaded method, and we get a sum of 10. And with overloaded methods, not only are the numbers of parameters taken into account, but the data type for each specific parameter. So this time, let's create 3 more add methods, but these ones will accept double values instead of integers. So let's change any instance of int to double, including the return type. Alright, and then I'm going to change the number of the overloaded method that we're using. So 6, 5, 4, 3, 2, 1. Our first 3 methods only accept integers, and they will accept between 2 and 4 integers. Our next 3 add methods only accept double values, and they accept between 2 and 4 double values. So we could also pass in some double values to our overloaded methods. Let's change these to 1.0, 2.0, 3.0, and 4.0. And we will need to change the data type of our variable x as well. So double x add 1.0 through 4.0, and we are now using overloaded method number 6, which accepts 4 double arguments. In summary, overloaded methods are methods that share the same name but have different parameters. They can share the same name, but they would need different parameters to give each method a unique method signature. Some factors that are taken into account with parameters are the number of parameters, the data type, and the order of the values. So if you would like a copy of all this code, I will post all of this in the comments down below. Please don't forget to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.
New Head & Shoulders Bare. Clinically proven dandruff control with just 9 essential ingredients. No sulfates, no silicones, no dyes. Dandruff control. Minimal ingredients. Job done.
Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about the printf method in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Hello all, welcome back to another video. For this topic, I'm going to be explaining the printf method. This is an optional method to control, format, and display text to the console window. Here's an example of the printf method, and this is different from print and print line. With the printf method, there are two arguments we need to place within the parentheses of the printf method. The first is a format string, a string that you would like to display to the console window. And second, we can add either an object, a variable, or a value. To keep it simple for now, I just added a value of 1, 2, 3. So we can format some value and place it at some position within the string. The position in which we want to add this value, whatever it is, can be added to wherever we add a format specifier, which is represented by a %sign. Let's say we would like to add this value at the end of our format string, so we would add a format specifier at the end that is represented by the %sign, and there is a certain amount and number of combinations and characters that we can add after this format specifier, and this will format our value a certain way. If we simply need to display a decimal number, we're going to add a D. It's kind of like a secret code. That's how I think of it, at least. So if we add a %sign and D, we will add this decimal value at this position within our format string, and that will appear down here. I could place this format specifier someplace else, and this value would be added to wherever I put this format specifier. So if I added this format specifier to the beginning of my format string, then this value will appear at the beginning of my string. So with the printf method, you need a format string and either an object, a variable, or a value. Depending on where you place this format specifier, the %sign, your value or variable will appear at this location. Think of it as you're replacing the format specifier with this value, and depending on the combination of flags, numbers, and characters after this format specifier, this is going to format and display your value a certain way depending on what combination of letters and characters comes after. Let's begin with conversion characters. This is a letter that appears after the format specifier, and the conversion character corresponds with the data type of the value that we're attempting to add. So D corresponds with decimal numbers, so we could add an integer at this location. So let's go over a few of the conversion characters that are available to us, but we'll need to create a few variables to do so. So let's begin with a Boolean. Let's call this my Boolean, and I will set this to true. We'll need a character, so let's say char, my char equals, and then pick a symbol that you want to use. We'll need a string, my string equals maybe your name. We'll need an integer, int, my int, and assign it a number. I'm just going to pick one at random, let's say 50. And let's add a double value. So double, my double equals maybe 1000. Okay, so these are not all of the data types that are available to us, but a few of the more common ones for beginners. So let's use the printf method and cover a few of the conversion characters. So we will need to use the printf method, system.out.println, printf, and let's just use the format specifier. So if we need to display a Boolean value, that would be % then B for the conversion character to display a Boolean. And we need to add a second argument. That is the value that we're attempting to add. So let's add my Boolean. And we can now display whatever this value is. So for characters, that is actually %. %C. And let's display my character. Okay. So strings are %S. So let's copy this, paste it. That is %S. And this will display a string. Should probably get rid of that line too. Okay, and integers are D for decimal. But we've covered that already. So %D for a integer. Let's display my int. Which displays 50, and %F for a double value. So that's for floating point numbers and double values. So let's display my double. So remember, with conversion characters, these are certain letters that follow the format specifier, the %sign, and in order to display a certain object, variable, or value, you need a matching conversion character to follow after the format specifier. B for booleans, C for characters, S for strings, D for integers, and F for floats or doubles. Our next field is the width field, so I already created some notes on this. The width field sets the minimum number of characters to be written as output. So here's an example. We have a format string, and we would like to display a value that is of the string data type. So let's say at the end we're going to add %s to display this string. We can set a minimum number of characters to display. So let's say we want to display at least 10 characters for this string. So before the conversion character, we can set a width, and this is a number. So if we want 10 spaces worth of room to display this string, we would add 10 or some other number before the conversion character. So before we display this, I'm just going to turn these lines into comments, and we will display hello plus my string, which states bro. So this prints a minimum of 10 characters for the name, including the length of the name. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the space that was here already too. So you can set a width, and this will display a minimum number of characters to be written out. And if you set this to be a negative number, that's actually a flag that we'll get into in just a little bit. That'll actually left justify the text within the space that we're allocating to display this value. So this text is now left justified, but all of that empty space now comes after my text, my string. Next on our list is the precision field, and what this will do is set a number of digits of precision when outputting floating point values. These include the data types of floats or doubles. Here's an example. I have a format string that states you have this much money, and then we have a format specifier that will display my double. This is the default, so we need at least %f, and this will display 1000 as well. As 6 zeros after our decimal, we can limit the amount of digits that will display after this decimal by using the precision field. So we write this before the conversion character. Let's say we would like to limit the amount of digits that we have after this decimal to 2 to represent cents. So I'm going to add 0.2 for 2 digits. and this will limit the amount of digits that will appear after the decimal portion. And if we change this to a different number like 1, well then this will only display 1. So that is the precision field. It will set a number of digits of precision when outputting floating point values. And lastly, we have flags. These will add an effect to output. Based on the flag added to the format specifier. Here's a few. We can left justify, we can output a plus or minus sign for a numeric value, we can have numeric values be padded with zeros, and we can separate large numbers by the thousands by using a comma. Let's try a few of these out. Let's copy what we have for our example for precision. So I'm going to copy this line and let's get rid of the precision. So we have %f. Let's left justify this. So I'm going to set a width, maybe 20, and set this to negative. So this will left justify all of that. Although it's a little difficult to see, I'm going to get rid of the left justify, and this will now be justified. So this would be useful if you need to line up a bunch of numbers. We can output a plus or minus sign for a numeric value. So I'm going to add plus F, and this should be plus 1000. If this was a negative number, like negative 1000, this should appear as a minus now. We can also pad our number with zeros. So let's set a width of maybe 20, and we will right justify it so we do not need a negative sign, and we are going to add 0. So we now have a bunch of zeros before our number of 1000. And lastly, we can separate each thousands place with a comma simply by adding a comma as the flag. So percent, comma, F. So at the the 1000s place, we now have a comma. So that is all what the printf method is. It's an optional method to control, format, and display text to the console window. We need at least 2 arguments, a format string, as well as either an object, a variable, or a value. We can add a format specifier within this format string and add a combination of characters and numbers to format our variable, value, or object a certain way. So that is an intro, more of a crash course to the printf method. If you would like a copy of all this code, I will post everything in the comments down below. This video was a lot of work. Feel free to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow.
From idea to submission, empower students to do their best work with Grammarly's generative AI. What if they could jumpstart ideas for any assignment? What if they could cite sources instantly? What if they could get real-time feedback? Prepare students with trusted AI writing assistants. Download Grammarly for free today.
Oh, bro. How's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about the final keyword in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Okay, ladies and gentlemen, I'm going to be teaching you guys about the final keyword. Anything that is declared as final cannot be changed or updated later in your program. Here's an example. Let's say we have a double variable called pi, and we will store the first few digits of pi. 3.14159. There's still more digits than that, but that's good enough for this example. And let's update the value of pi to maybe 4. And then within a print line statement, let's print the value of pi. So this will display 4 because we updated our variable pi to equal 4. So if we were to use the final keyword, when we declare our variable, we're going to precede our data type with the keyword final. And we can no longer update this value, and it states The final local variable pi cannot be assigned. It must be blank and not using a compound assignment, so we can no longer change the value of pi. We're going to run into a problem, and it states here that we ran into an unresolved compilation problem. So if you declare anything as final, you cannot update it. It is final. That's the law. You can't update it. And one common practice that people will do when they declare something as final is that with the variable name, they will make all the letters uppercase. It's not necessary, that's just common practice. And when we run this program, it displays our number pi of 3.14159. So really, that's the basics of the final keyword. Anything that is final cannot be changed once you declare it. If you would like a copy of this code, I will post this in the comments down below. But yeah, that's how the final keyword works in Java. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys all about object-oriented programming in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey, welcome back. This video is the start of the object-oriented programming portion of the series. The abbreviation people use is OOP, also pronounced as OOP. Now, objects, they can be intimidating, but they're really not that bad once you get to know them. So look around you right now. You are surrounded by different objects. Next to me, I have a phone, a desk, a computer, and a coffee cup. And you can hear me knocking on it right now. Unfortunately, it's empty. So we can use programming to imitate objects in the real world. Anything you can think of, really. An object uses a class. For example, I have a class called car, and we're going to be constructing some car objects. So with objects, they contain attributes and methods. Think of attributes as the characteristics that this object has, and methods as the different actions that this object can perform. For example, let's list some of the attributes of a coffee cup. These are the characteristics of my coffee cup. So for example, let's say that the color of this coffee cup is white. I could store this within a string variable within the class called color, and we can assign this a string value such as white. What about a temperature? That could be a double variable, and let's say that this is room temperature at 20 degrees Celsius. And then what about a status like if it's empty or is it full? This could be a Boolean value such as true or false. And unfortunately, my coffee cup is empty, so empty will equal true. Now, what kinds of methods, what kinds of actions can this coffee cup perform? Let's say we have two. A drink method, and when we call this method, we can print a message such as, you drink from the cup. Or what about a spill method? If we were to call the spill method in case I decide to spill my coffee everywhere, we could say, you spilled your coffee everywhere. So all an object really is a bundle of defining attributes and methods, the characteristics of an object, and what actions that this object can perform. And for today's video, we're going to be creating some car objects. Why? Because, well, I like cars. So we need to create a different class, another class. So you can either do this within the same Java file or a separate Java file. So if you were to create a class within the same Java file, make sure that you declare this class outside of the main class that you're working with. But I like to keep my code organized into different Java files. So for me, I'm going to create another Java file. So within my project folder, I'm going to go to File, New, Class, and I'm going to call this class car because we're constructing car objects, and then click Finish. So I have two classes within my project folder, one called main, for you it may be named something different, and a car class. So we're going to be using this car class to define the attributes and methods of what our cars should have. But if you decide to write this within the same Java file, you'll probably write something like this, but I'm just going to keep these as separate files. Now, what kinds of attributes should our car have? Let's start defining a few. Let's say a make and model. These could be string variables. So let's say string make, and pick one of your favorite cars. Let's say string make equals Chevrolet. And we could also have a model, like string model equals Corvette, because I like Corvettes. What about a year? This could be an integer, int year. And let's say this is a 2020 Chevrolet Corvette. What about a color? String color equals maybe blue. And what about a price? This could be a double variable such as double price. Let's say that this car is 50,000 US dollars and 0 cents. That's probably enough attributes for this. Example. Now, what kinds of actions, what kinds of methods would we like our car objects to be able to perform? Let's define two methods, a method for drive and a method for brake. So let's define these. Let's say void drive. And what do we want to do when we call this drive function? Let's have a simple print line statement that says you drive the car. Let's also create a method called brake. Void brake. System that out.print. Line. You step on the brakes. And that should be good for this example. So these are all of the attributes of the car, the defining characteristics, and these are the methods, what actions our car object can perform. Now let's head back to our main class. This is how to construct an instance of another class. We're going to be constructing a car object. So first we begin with the name of the class, which is car. Next, we can create a unique name for this instance of the class, this unique car object, and I will just call this my car to keep it simple, equals new, and then the name of the class again, followed by a set of parentheses, then a semicolon. So my car now has these attributes. It's a 2020 Chevy Corvette that's blue, and the price is $50,000, and it has two methods, a drive method and a brake method. So let's display some of the characteristics of this car. We can do that within a print line statement, and if we want to display or access one of the attributes of this car, we type in the name of the car, which is my car, dot, and then whatever attribute you want to display. Let's display the model. So when we run this, we'll create a car object, and it's called my car, and we're going to print the model, and in the console window, it's going to display the model. Let's display a few of the other attributes too. So let's repeat the process. We type in the name of the object. The name of this object is called my car. I would like to access the make this time, and the make is an attribute, a variable found within this class. So this is going to print the make and the model, and this is a Chevy or Chevrolet Corvette. Now, what if we want to access or perform one of these methods? It's the same process as before, really. So we type in the name of the object, dot, and then the method we would like to call. So we are looking for the drive method, and that is right here. And let's turn these two lines into a comment. So we're going to call the drive method of my car. And it says you drive the car in the console window. Now let's apply the brakes. So we type in the name of the car or the object, dot, and we're going to use the brake method this time. You step on the brakes. Now with classes, we can reuse a class to instantiate multiple instances of this class, meaning that we can reuse this class to create multiple objects, not just one. So let's reuse this car class to create a second car. Let's pretend that we own two cars now. So let's repeat the steps for creating a car. So we type in the name of the class, car, and we need a car 2 following these same steps. So in order to display these, let's write this within a print line statement. So we are working with my car 2. We are going to type that name, my car 2, followed by whatever we want to access. We would like to access the make as well as the model. So I'm going to change this to my car 2 dot model. And I'll add a print line statement just to help separate these within the console. Console window. So what we get is that both of these cars, my car 1 and my car 2, are both Chevrolet Corvettes. So the reason behind this is that with our car class, it's acting as a blueprint, and we're saying that whenever we construct an instance of this class, a car object, all of them are going to be Chevrolet Corvettes, the year 2020, they're blue, and they are all $50,000. And they only have a drive and brake method. And to solve this problem, because we don't want all of our cars to be Chevrolet Corvettes, I mean, that wouldn't be a bad problem to have in real life though, but it's not practical for programming. So what we're going to be doing in the next video is learning about constructors, how we can construct objects that have different characteristics, different attributes, so that all of our objects are not the exact same. So if you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's an introduction to object-oriented programming in Java.
U-Track's built-in knowledge base is, well, it's whatever you want it to be.
Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about constructors in Java, so sit back, relax, and enjoy the show. You too can become a hero and save our channel by punching the like button, throw a comment down below, and smash the subscribe button. Alright guys and gals, in this video I'm going to be explaining constructors to you all. Now, a constructor is a special method that is called when an object is instantiated. And when we instantiate something, that's just a fancy term for creating an object. Now, for this example, I have two classes. I have my main class that contains my main method, and I also have another class within my project folder called human. We're going to be creating some human. Today. Now, normally the steps of creating an object, we would type in the name of the class. For this example, it's human, a unique name for this specific object. We'll just call this human, all lowercase, equals new human. Now, this portion works very similar to a standard method call, except a constructor is a special method that works behind the scenes that will create an instance of a class for us. It will instantiate an object. Basically speaking, our constructor is acting as a special method, and we can even pass in arguments when we instantiate it. So if we would like to do something with these arguments, like assign them to the attributes of our object, we can set up the constructor within the class. So this is how to create the constructor within our class. It's going to have the same. For this example, it's human, followed by a set of parentheses and then a set of curly braces, and that's it. We have our constructor. So when we create an instance of this class, it's going to call the constructor much like a method, and anything within the constructor will be performed just like a standard method. So we can actually set up some parameters and pass in some arguments when we create our object. So let's set up some parameters for our human class. What are a few attributes that a human might have? For one, a name, like Bob or something. So let's define the first parameter of string name. Perhaps an age, int age, and then a weight. Actually let's make this a double weight. So we have now set up 3 parameters for this human class. Let's head back to our main class. Now we're going to have a problem. That's because we do not have matching arguments to send our human. That's because we're saying that in order to construct a human, these are the parameters, these are the rules. In order for us to instantiate a human, to create a human object, we need to send our constructor a string, an integer, and a double value to serve as the name, the age, and the weight. So in order to get this program working, within the constructor, we need to pass in some matching arguments. So we need to send a string, an integer, and a double value. So let's call our human Rick, and we'll pass in Rick for the first argument. Let's send an age, perhaps 65, so he's elderly, and then a weight. Perhaps this will be in kilograms. So let's say maybe 70. See, now that error went away, so we can compile and run this, but it currently doesn't do anything. So why is this useful? Why is passing arguments to a constructor useful? Well, this gives us the ability to create different objects that have different attributes. So we could create a second human that has a different name, a different age, and a different weight. But we first need to assign these values to the attributes of our class. So let's head back to our human class, and we need to define a name, an age, and a weight. And let's do this outside of the constructor, but we're not going to assign a value just yet. So let's say string name. We're only going to declare this int age and double weight. And then within the constructor, we're going to assign all of these values to each of these variables. So right now, let's say name equals name, and age equals age, and weight equals weight. Now, this actually isn't going to work, and I'll show you why. So let's attempt to access human one's name. And let's do this with a print line statement. System.out.println to access one of these attributes. We type in the name of the object, dot, and whatever we're trying to access. Let's attempt to access the name. Now, if we were to display the name, it says null. Well, what gives? That's because we need to assign each of these values to this specific object, and one keyword to assign value. To this object is to use the this keyword. So when we assign name equals name, age equals age, and weight equals weight, we're going to precede each of these with the keyword this. This dot name, this dot age, and this dot weight. So for all intents and purposes, when we create an instance of a class, when we create an object, we're going to imagine or pretend that we're replacing this keyword with the name of the object. So if we're creating an object called human, replace this or pretend that we're replacing this with human. If we created a second human object, this could be human 2. just pretend that, but stick with the keyword of this. So now if we were to run this, human now has a name. Now let's create a second human. So let's repeat the steps. Human, I'm going to call this human2 and rename. Name human as human1 just to keep things simple. Now we can send different arguments to our constructor. So we need to send a name, an age, and a weight. Well, a string, an integer, and a double. So for our second human, let's call him Morty. We need to send an integer. Let's say he's 16 and he weighs 50 kilograms. And let's attempt to access human2's name. So we can do this within a print line statement. Human2 dot name. And this should display Morty. So now the point of constructors is that they allow us to construct objects that have varying attributes. And in the last lesson, when we were constructing cars, we were only able to construct blue Corvettes. And with the help of constructors, we can construct objects that have different qualities. So they are still humans, they're objects that are instantiated from the human class, but they have different attributes that make them unique. Here's one situation that you might run into. Now, how can you access an object's attributes from within its class itself? So we can utilize the this keyword to help us with that. So let's pretend that humans have two methods. They have an eat method as well as a drink method. And let's define these both. So for eat, let's say void eat. And within this method, let's create a print line statement that says, this person's name is eating. So in order to access an object's attributes from within its own class, we have to use the this keyword. So if we want to display the person's name plus maybe some text such as is eating, let's type in this dot name to access this object's name plus is eating. So this will print the person's name plus is eating. And let's try this. So let's say human2, which is Morty, is eating. So in order to call this method, we'll have human2 use its eat method. So this will display Morty is eating. Now let's create a drink method. Void drink. And we will display this person's name is drinking. System.out.println this dot name plus is drinking burp. And let's say human1, which is Rick, is going to use the drink function because he likes drinking. So human1 dot drink. And here are the results. Morty is eating and Rick is drinking. That's because we stated that human2 is going to use its eat method and human1 is going to use its drink method. So if we had each of these objects perform the other method, a different method, let's say human1 is going to use the eat method and human2 is going to use its drink method. So now each of these objects is using a different method. This time Rick is eating and Morty is drinking. So that's why constructors are useful. They allow us to assign different attributes to each object that we instantiate. So that's the basics of constructors. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of constructors in Java.
Old Spice shampoos are scientifically crafted to help make men's hair look thicker, healthier, and more moist.
Java. Hey, how's it going everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys the difference between local and global variables and objects in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, I'm going to explain the difference between local and global variables and objects. So anything that is local is declared inside a method and is visible only to that method. Anything that is global is declared outside a method but within a class and is visible to all parts of a class, including any methods found within that class. Here's an example. We're going to create a program where we will roll a dice. So let's handle that with an additional class. So let's go to File, New, Class, and I will call this class Dice Roller. Click Finish. I need to create an instance of this class, so within my main method, I'm going to create an instance of my Dice Roller class. Dice Roller, I'll call this instance Dice Roller for short, equals new dice roller. Within our dice roller class, we'll create a constructor. for this class. It's the same name as the class name, plus a method to roll a dice for us. So the return type is void, and we'll call this method roll. We'll need to declare a few things: an instance of the random class, plus an integer variable to hold our result. So let's create an instance of the random class. Random equals new random. We'll need an import as well, so include that. Import java.util.random. And an integer variable, and we'll call this number. Int number, and we'll set this equal to 0 for now. And lastly, within the constructor, we'll call the roll method. So let's set up the roll method. We're going to take our number variable, set this equal to random.nextInt. We want the numbers 1 through 6, so we'll pass in 6 to this method of nextInt plus 1. And we're adding plus 1 because we would normally get the numbers 0 through 5. And then with a print line statement, we'll display our number to the console window. Here's the issue we're running into. Both our instance of the random class plus our integer number variable are local to our constructor. So anything that is local is declared inside a method and visible only to that method. Well, our constructor counts as a method, so the instance of the random class and our number are only visible to anything within our constructor. Our roll method does not have access to our instance of the random class plus our number. There are two ways in which we can solve this. One is that we can pass these as arguments to a method, and the other way is that we can declare these as global. So let's begin by passing these as arguments. So we're going to pass our instance of the random class plus our number as arguments to our roll method. So let's do that. We're going to pass random and number to our roll method, but we'll need to set up some parameters. This will accept a random argument as well as an integer argument, and we'll call this number. So this will work just fine then. So we have a 4 and a 4 and a 6. So the other way in which we can write this, I'm just going to reverse our changes. We can declare our instance of the random class and our integer number variable as global. These are declared outside a method, but within a class. it's visible to all parts of a class. So in place of declaring these inside of the constructor for the dice roller, we're going to declare our instance of the random class and our number outside of this method, our constructor. And with our random class, we'll finish instantiating this within the constructor. So let's declare random outside. The constructor, as well as our number outside of the constructor as well. So now our roll method has access to our instance of the random. Class plus our number, because these are global. They are declared outside of the method, but within a class. Technically, we don't even really need to assign a value anymore to our number. We can simply just declare these. So this will work just the same as it did before. It's just another way of writing this program. We rolled a 5 and we rolled a 4. So that's the main difference between local and global. Anything that is local is declared inside a method and visible only to that method. Anything that is global is declared outside a method, but within a class, and is visible to all parts of a class. So that's the differences between local and global items in Java. If you would like a copy of this code, I will post all of this in the comments down below. But yeah, that's the main differences between local and global items in Java.
Want to become a certified project manager but aren't sure about the skills you need? The PMP certification prep course on Udemy is just the thing. Learn the basics of project management and get yourself ready for the PMP certification exam. With anytime access on mobile or desktop, you can plan your learning around your life.
Hey, what's going on everybody? It's your bro here. Hope you're doing well, and I have a special treat for you guys in this video. We're going to be using overloaded constructors to bake some pizzas. So